I see a confusion matrix. It's a table showing how many times the model correctly or incorrectly classified cats and dogs. The rows represent the actual animal, and the columns represent what the model predicted. For example, the top left cell shows how many actual cats the model correctly classified as cats, 100. This is the number of true positives for cats. That means the model correctly predicted 100 images of cats as cats. This is the number of false negatives for cats. The model incorrectly predicted 20 images of cats as dogs. This is the number of false positives for cats. The model incorrectly predicted 15 images of dogs as cats. This is the number of true negatives for cats. The model correctly identified 165 images of dogs as dogs. This statement checks the model's precision for cats. Precision is calculated as true positives for cats, true positives for cats plus false positives for cats. I find that the precision value is actually closer to 87%, 100 plus 15, not 83.3%. Let's check the recall for dogs. Recall, also called sensitivity, is true positives for dogs, true positives for dogs plus false negatives for dogs. The calculation confirms this statement is correct. 165 plus 15, is approximately 91.7%. The F1 score balances precision and recall. It's calculated as 2 asterisk, precision asterisk recall, precision plus recall. While the statement is incorrect, I recommend you calculate the F1 score for cats and dogs to verify. Accuracy shows the overall correctness of the model. It's true positives plus true negatives, total number of images. I calculate this as 100 plus 165, 100 plus 20 plus 15 plus 165, which is approximately 87.5%. This statement is correct. This refers to the actual, true category of the image. In other words, the actual animal in the picture. It does not refer to how the model classifies the picture. Similar to actual cat. This refers to the actual animal in the picture, a dog. This refers to how the model classified the picture. In this case, the model predicted the picture to be a cat. This refers to how the model classified the picture. The model predicted the picture to be a dog. I am evaluating the performance of the model used to classify images of cats and dogs. I'm looking at a confusion matrix, a table that shows how well a machine learning model performed on a classification task. The rows represent the actual classes, in this case, cat and dog, and the columns represent the model's predictions. Each cell shows the count of instances that fell into that combination of actual and predicted class. This is a fundamental tool for evaluating model performance. This column shows the number of images the model predicted to be cats. The model incorrectly predicted 20 actual dogs as cats, false positives. The model incorrectly predicted 15 actual cats as dogs, false negatives. The model correctly predicted 165 actual dogs as dogs, true positives. Let's break down precision. Precision measures how accurate the positive predictions are. For the cat class, I'll calculate it as true positives plus false positives. That's 100 plus 15, giving approximately 87%, not 83.3%. There's a slight discrepancy perhaps due to rounding differences in calculations. Recall tells us how many of the asterisk actual positive cases the model correctly identified. For the dog class, the recall is calculated as true positives plus false negatives. That's 165 plus 15, which equals approximately 91.7%. So, statement B is correct. The F1 score balances precision and recall. It's the harmonic mean of the two. I find the F1 score for each class by using this formula. 2 asterisk, precision asterisk recall, precision plus recall. I then compare the two F1 scores. In this case, the statement is false because the F1 score for the dog class is slightly higher. Accuracy tells me the overall correctness of the model. I calculate it as true positives plus true negatives, total number of instances. This means 100 plus 165, 100 plus 20 plus 15 plus 165, which comes to 87.5%. So statement D is correct. This row indicates the actual number of cat images in the dataset. This row represents the actual number of dog images in the dataset. This column represents the number of images the model predicted to be dogs. The model correctly identified 100 actual cats as cats, true positives. This problem focuses on evaluating how well a machine learning model does its job. We use metrics derived from the confusion matrix to determine this. I'll use this table to calculate the performance metrics of the cat and dog classification model. It shows how many cats and dogs were correctly and incorrectly classified. For example, 100 cats were correctly identified as cats, true positives, but 20 cats were mistakenly classified as dogs, false negatives. Similarly, 165 dogs were correctly classified, and 15 dogs were wrongly identified as cats. This row represents the actual number of dogs in the dataset. I'll compare this to the model's predictions to calculate recall for dogs. Recall tells me how well the model finds all actual dogs. This column shows the number of images the model predicted to be cats. I'll use this to calculate precision for cats. Precision tells me how many of the images classified as cats were actually cats. This column shows how many images were predicted to be dogs. I'll use this number to calculate precision for dogs. This is the number of true positives for cats. The model correctly identified 100 cats. This is the number of false negatives for cats. The model incorrectly classified 20 cats as dogs. This is the number of false positives for dogs. The model mistakenly identified 15 dogs as cats. This is the number of true positives for dogs. The model correctly identified 165 dogs. This introduces the multiple choice quiz based on the provided confusion matrix. I need to assess the model's performance using various metrics such as precision, recall, F1 score, and accuracy. Let's see how well the model performed. This is the problem statement of the quiz that I am about to solve. I have to answer the multiple choice questions based on the performance of the model. This is the first multiple choice option, which is related to the precision of the cat class. I'll calculate the precision of the cat class and verify if this option is correct or not. This is the second multiple choice option, which is related to the recall of the dog class. I'll calculate the recall of the dog class and verify if this option is correct or not. This is the third multiple choice option, which is related to F1 score, a metric that combines precision and recall. I'll need to calculate the F1 score for both classes to verify this statement. This is the fourth multiple choice option, which is related to overall accuracy. I'll calculate accuracy and check if the statement holds true. Let's solve this. The goal here is to understand how well the machine learning model performs at classifying cat and dog images. This involves calculating various performance metrics and interpreting the results. We're tasked with evaluating a machine learning model's performance using a confusion matrix and answering multiple choice questions about its precision, recall, F1 score, and accuracy. We analyze the confusion matrix to understand how well the machine learning model is performing. I'll look at the number of correct and incorrect predictions to evaluate its accuracy, precision, recall, and F1 score. This is the question I'm trying to answer using the confusion matrix. I'll evaluate each statement using the calculated metrics. This table shows the model's predictions versus the actual categories. I use these values to calculate various metrics that reveal the model's performance. This represents the actual image category as a cat. This represents the actual image category as a dog. This column indicates how many images the model predicted as cats. This column indicates how many images the model predicted as dogs. The model correctly predicted 100 cat images as cats. This is a true positive, TP, for cats. The model incorrectly predicted 20 cat images as dogs. This is a false negative, FN, for cats. The model incorrectly predicted 15 dog images as cats. This is a false positive, FP, for cats. The model correctly predicted 165 dog images as dogs. This is a true positive, TP, for dogs. I'm looking at a confusion matrix, which is a table showing how many times the model correctly and incorrectly classified each category, cats and dogs in this case. The rows represent the actual categories, and the columns represent what the model predicted. To calculate precision for cat, I take the number of cats correctly identified, 100, and divide it by the total number of things the model predicted as cats, 100 correct plus 15 incorrect. This gives me the proportion of correctly predicted cats among all predicted cats. It's approximately 87%. The F1 score for cat balances precision and recall. First, I calculate recall, see line 8. Then I compute the harmonic mean using the precision and recall values to get the F1 score for cat. For the overall accuracy, I add up the number of correctly classified cats and dogs, 100 plus 165. Then divide by the total number of images, 100 plus 20 plus 15 plus 165. The result is the overall accuracy of the model, which is approximately 87.5%. This is a multiple-choice question testing your understanding of how to interpret the results from the confusion matrix and calculations. This statement is checking your understanding of precision calculations based on the confusion matrix values, comparing it with your calculated value from line 6. This statement tests if you correctly calculated recall for the dog class based on the confusion matrix, comparing it to your calculated value in line 7. This statement checks if you understand that the F1 score balances precision and recall and how it compares between classes based on your calculations from lines 8 and 9. This tests if you correctly calculated the overall accuracy of the model using the confusion matrix, comparing it to your calculated value in line 10. I'm evaluating how well a machine learning model performs using a confusion matrix. Think of it like a report card for the model showing its successes and mistakes. This is the specific report card, a table showing the model's predictions versus the actual categories. These are the true categories of the images, whether they were actually cats or dogs. These are what the machine learning model guessed the image categories were, cat or dog. The column represents the model's predictions of the cat category. The column shows the model's predictions of the dog category. This row shows how the model performed when the actual image was a cat. This row shows the model's performance when the actual image was a dog. The model correctly identified 100 images as cats. This is a true positive, TP, for the cat category. The model incorrectly identified 20 images as cats, when they were actually dogs. This is a false positive, FP, for the cat category. The model incorrectly identified 15 images as dogs, when they were actually cats. This is a false negative, FN, for the cat category. The model correctly identified 165 images as dogs. This is a true positive, TP, for the dog category. I'm asking you to determine which statements about the model's performance are accurate based on the confusion matrix. Precision for cats measures how many of the model's asterisk cat predictions were actually correct. Recall for dogs measures how many of the asterisk actual dog images the model correctly identified. The F1 score is a combined measure of precision and recall. It balances both. Accuracy represents the overall correctness of the model's predictions.